Hey, what's up? Welcome back. Patrick here from All Things Mathematics, and moving on to the next example on the test. Here we have to find dy dx when x is -3, for when y is equal to 3u squared plus 4u, and u is equal to the square root of x squared plus 16. So hopefully, when you read this, you could recognize that we're going to be using Leibniz notation to find this dy dx, right, which is a different type of chain rule. We went over this in the lecture videos. If you're not familiar with this or you need a refresher, perhaps go back to the lecture videos, go through the fundamental examples that I went through when I introduced Leibniz notation. When I'm going through this, I'm assuming you have an understanding of how it works. So let's go through these one by one. So what's dy du going to be? Well, we would just take the derivative of this, 3u squared plus 4u. That's going to be what? 6u plus 4, like that. And then what's du dx going to be here? Well, first what I'm going to do is I'm going to change the u function to be x squared plus 16 to the power of a half, like that. And then from here, let's find the derivative. We could use the chain rule, right? So du dx, it would basically be, we could bring the 1 over 2 down, keep the inner function the same, subtract 1 from the exponent, and then multiply it by the inner function, the derivative of the inner function, which is 2x, like that. And then notice that these 2's cancel out, and then this x squared plus 16 to the negative a half, we could bring down. This x here stays at the top, right? So that would be like x squared plus 16 to the power of a positive a half, which is like x over root x squared plus 16, like that, right? So this du dx ends up being this right here, right? So we took the derivative of those two separate functions, and now we can go into plugging in this actual x value of -3. So notice this x value of -3, we could plug in for this bracket, right? So what would we have here? We would have -3 over the square root of -3 squared plus 16, like that. However, notice that for this bracket, we have to plug in a u, right? We can't just plug in this x value -3 for u. Okay, so how are we going to do that? Well, we have to get a u value. We would plug in this x value of -3 into this expression right here. And notice that when we do that, we would have what? -3 squared, which is 9, plus 16 is 25. So when x is -3, u is equal to root 25, which would be 5, like that. And then this 5 we plug in for this bracket, this u value of 5, right? So when x is -3, u is equal to 5, and then we plug that in here. So that'd be 6 times 5, which is 30, plus 4, that would give us 34. And then from here, we just have to multiply these, right? So this is like 34 over 1. So 34 times -3, that would give us -102. And then this is going to be root 25. Root 25 is just 5, like that. So this ends up being -102 over 5. That ends up being the final answer for this question, right? So doing the chain rule, however, in a different way with Leibniz notation. In the lecture videos, I've gone through a bunch of examples of doing the chain rule in these two different ways. In that standard way, right, where we take the derivative, just like we did here actually, where we take the derivative of the outside function, keeping the inner function the same, and then multiplying it by the derivative of the inner function. But you could also do the chain rule in this way, where you split up the functions like this, right, and then get the values. So final answer for this question, -102 over 5. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.